Hello everyone, this is a video lecture for Calculus 2, section 11.7, Strategies. And there's nothing new to talk about. This will actually be very fast. Should have probably combined it with the last section. 11,7,009. We have summation of n squared minus 1 over n cubed plus 1. And they say converge, diverge. Well, this is something similar to saying 1 over n. Basically, the 1's go away. You can cancel this to make like a 1 down there, 1 power. And so 1 over n. Well, this is a p series. And because it's a 1 power, it actually is going to diverge. It's the very last one that diverges. Okay, 11,7,013. I have summation e to the n power divided by n squared. They say converge or diverge. Well, what we have here in the top is an exponential. We have the bottom as a polynomial. And exponentials are way bigger than the polynomial. So we got a huge number, and then we got just something that's kind of all right. And you can see that this is going towards infinity, and thus that will also diverge. Nothing new here, just another problem. 11,7,003, because we want to go backwards now. Summation of -1 to the n power of, I think that's an an? Or is that a 9? 9n, yes. Sorry, my handwriting's so bad. 9n, 9 times n, divided by n plus 3. Now this is an alternating, and so what we're going to have to do is just take the limit of this guy by itself, and you can see that the n's are going to cancel one another, leaving a 9, which is not equal to 0, and so this is diverges for sure. Okay. Yeah. Well, there we go. I actually have something in my notes that doesn't make sense there, but whatever. I'm pretty sure it's good. My answer was diverges, and it's correct. So 11,7,015. And so I got summation n equals 9. I'm going to write it because it's a little different than normal. Almost everything else is 1. And then I have 1 divided by n square root of ln of 4n. Oh, so going way back, this has been a couple sections, we have done 1 divided by n times ln of n, and this diverges. And the reason why it diverges is because the ln has a 1 power there. And so what we're faced with today, right now, is basically what we had already seen on another problem. Not n power. I'm going to call it, yeah, p power. P power. That's just half is what that is. So my p equals half in this particular case. And so I'm wanting to know if this converges or diverges. I know that this one diverges when it's a 1 power, but what happens if it's a half power? What if it's squared? So note for just a second that let's just say I put like a 2 down here, or even better, let's put like a 200. So like if we put a big number in the bottom, what it's doing is, I like to call it helping. It's helping the bottom get bigger because that's what it's doing. You got a number here and you say 200 power. Here, what's 2 to the 200 power? Boom, it's infinity, right? So what I'm getting at is that number up here, if it gets bigger, then it's helping the bottom get bigger, which goes to a converging kind of understanding. And we already know that p equals 1 diverges, okay? So that's kind of the cutoff line. And it feels like p greater than 1 is going to converge because it makes the bottom bigger. So what we have in our particular case is a half. That's less than 1. So in this case, I'm going to say it diverges, okay? Because what happens is that the square root of ln n is much less than ln n. I know that infinities, if I start, and I do this so often, I just throw an infinity in there and like, oh, of course. But the square root of infinity is actually less than just a plain old infinity. You got 1,000 and you take the square root versus just a plain old 1,000. This is always less. And so your bottom is smaller, therefore the top is bigger, and therefore it's going to diverge. So a lot of reasoning there, I guess. None of that's bad math. It's just kind of a reasoning, a comparison. And I'm sure there's other methods. So 7 or 11, 7, 0, 2, 2. I've got summation of the sine of 9n all divided by 1 plus 4 to the n power. Okay. Converge or diverge? Well, do you know what the top is doing? Actually, it's really funny. It's alternating. Yeah, because the sine is going between -1 and +1. So it's going back and forth, back and forth. So this right here, you could technically almost replace it with just an alternating, and there you go. If there's alternating, you take the limit and all that stuff. But if you just look right here, your bottom has an exponential. So you got, I don't know, plus or minus 1 divided by an exponential is definitely going to end up going to 0, which is a converging moment. So, cool. That was it. Next problem. 11, 7, 0, 2, 3. I have summation. They use k's here, so I guess I'll write that. Of 9 to the k minus 1 times 4 to the k plus 1. And then I've got k to the k. All right. Well, I'm going to tell you this one converges. This one's actually the easiest here. Because what you have here in the top is an exponential, another exponential. You're like, man, those are pretty big guys right there. And you're multiplying them together. Gosh, that's going to be huge. Well, what you got down here is that power tower thing. This is absolutely the biggest thing that you can put down here. This is the biggest. Like on our big scale of blah, 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 blah. He was at the edge. He's at the very edge here, the very biggest that you can go. So you got the biggest bottom in the whole wide world. Like, what's the mass of Earth? No, what's the mass of the sun? And then, what's your mass? And you can see it's going to converge. Okay, awesome. And 11, 7, 0, 4, 7. I have summation of the nth root of 8 minus 1 all to the n power. Well, I'm going to actually do root test on this because of that n power. It does come in handy once in a while. So basically here, I got my nth root of 8 minus the 1 all to the n, and these guys cancel. And so I'm still trying to find the limit of this guy right here. And if I plug in infinity with this n stuff, we already determined that it goes to 0. And so, pretty interesting here. One thing about the root test is that we should do the absolute value of it, I believe. I can't remember if that was actually part of the formula or not. Like there's an absolute value of the root test or blah, 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 something like that. Because what you're going to end up with here is something or other. This ultimately here goes to a 0, I believe. I have equals 0 converges, and that was right. So, oh, I know. Right. The nth root, we discussed this already. It goes to a 1, and 1 minus 1 makes a 0 converge. There it is. All right, well, little things like that. And that was it. That's all I got for that section. So thank you very much. Have a great day.